Hello and welcome to Math with Mrs. Becker. Today in Calculus we are going to finish section 8.2 where we are looking at specifically the sine and cosine function. So the first thing that they want us to be able to do is take a triangle, and if they give us information, use sine, cosine, and tangent. So remember SOHCAHTOA, to be able to set up a trig equation so we can find a missing value. So here is our right triangle. The hypotenuse of a right triangle is 4. Remember, the hypotenuse is always across from the 90-degree angle. One angle is 0.7 radians. So right there, before I do anything else, we are in radians. So I'm going to go to my calculator. When you hit this key that says DRG, notice that currently my calculator is set to look at degrees. This problem is telling us we are looking at radians. So I need to go on over, select radians, and then I'd be ready to go. Okay, we want to determine the length of side X. So let's start off with side X first. They gave us an angle measure. So across from the angle, that is the opposite. Across from the 90, that is the hypotenuse. The third side is the adjacent. So if I am trying to solve for X, I need a trig function that has adjacent, so I can have the X in the problem, and hypotenuse, so I can use the 4 to help solve. Adjacent and hypotenuse is the cosine. So the cosine of the angle, cosine of 0.7, is adjacent X over hypotenuse 4. Now to solve for X, I need to multiply both sides by 4. So X has a measurement 4 times the cosine of 0.7. It says to round it to the 10th, so this would be 3.1. Now, again, I want to use the 4 that they gave me. Yes, I already calculated the 3.1, but if by chance this would be a mistake, I don't want this mistake to carry on into the next problem. So I'm going to use the given information, the 0.7 and the 4. Okay, so I'm looking at opposite and hypotenuse. So the sine of 0.7, sine is opposite y over hypotenuse 4. Again, if I want to know the length of y, I have to multiply both sides by 4 because I want to cancel that division. So y equals, I have 4 times the sine of 0.7. If I round it to the 10th, this would be 2.6. So that is the first goal of this part of 8.2. You will be given a triangle. They'll give you information. Using SOHCAHTOA, you will be able to set up equations to find missing values. The main thing is, if you see radians, your calculator must be in radian mode. Okay, now we're going to the unit circle. Another way to describe sine and cosine is to look at a point on the unit circle. Now remember, on a unit circle, okay, this is what it looks like. When you're looking at the unit circle, cosine of theta, sine of theta. So when you look at the ordered pairs around the unit circle, the cosine is X, the sine is Y. Now these are just some formulas that we did look at back in college trig. They're just kind of reminding you. Main thing is, if you're comfortable with the unit circle and you know cosine is the X, sine is the Y, we are good to go. Now here, what they want you to do, they're going to restrict the domain. So when I look at the unit circle, they want me to find solutions that are in between 0 and pi over 2. So if I look, this is 0, this is pi over 2. So I have a restricted domain, meaning if I don't have an answer in this first quadrant, it would be undefined. Now what they want, if I look at the cosine of negative pi over 3, if I go downwards, pi over 3. Okay, and the reason why I'm going downwards from the x-axis is because I'm looking at a negative angle. If I go downwards, here's my ordered pair. The cosine is the x value. So what I want to know is, in quadrant 1, where is the x value 1/2? So the x value is 1/2 at pi over 3. Okay, here's the next one. Cosine of 3 pi over 2. So I find 3 pi over 2. The cosine is the x value. So what they're saying is where in quadrant 1 is the x value 0. So I'd go ahead and look. The x value is 0 at pi over 2, but notice that's not included. If this had the little inclusive symbol, meaning I could include 0 and include pi over 2, well, we would have pi over 2 as an answer. But they did not include it, so there is no place in between where it's a 0. So this is undefined. But again, if the endpoints were included, then it would have been pi over 2. Cosine of negative 4 pi over 6, well, I can reduce that to negative 2 pi over 3. So when I look at the denominators of 2, or the denominators of 3, I need to go down 2 units. So from here, here's a denominator of 3, so there's 1. Here's a denominator of 3, so there's 2. Here's my ordered pair. The cosine, the x value is negative 1/2. So what they're saying is within this domain in quadrant 1, where is the x a negative 1/2? Nowhere. The x is always positive in quadrant 1, so it's undefined. So again, what we're looking at here is knowing that the cosine is the x value, understanding the domain limitations. Now we're going to go ahead and look at y's. So y is the sine. We're going from negative pi over 2 to pi over 2. So this time I can go upwards to pi over 2 and I can go downwards to pi over 2. So my restricted domain, I have to stay within this region. So I have to be looking at only quadrants 1 and quadrant 4. Okay, so that's what the restricted domain is. Now, you have to remember that the sine is the y value. So I have to find 7 pi over 6. So 7 pi over 6 is right here. The y value is negative 1/2. So if I look on this half of the unit circle, where is the y a negative 1/2? Well, that's right here. But here's the deal. This is like a no-fly zone. You can only go from 0 to pi over 2 and 0 to negative pi over 2. So I can't say 11 pi over 6 because that means I traveled all the way around to get there. I can't. I have to go downwards. The denominator here is 6, so I'm going down 1 pi over 6. So my solution is negative pi over 6. Okay, this was a typo on my part. This is supposed to be pi over 3. Okay, so if I look at pi over 3 and then I make it negative. So if I go pi over 3, the y value is square root of 3 over 2. But then notice they want us to make it negative. So y is negative square root of 3 over 2. So I need to look on that half of the unit circle. Where is the y? Negative square root of 3 over 2, right here. So the denominator is a 3. So from here, I'm going downward, so it's negative 1 pi over 3. Now this is asking me, the sine is y, the cosine is x. So they're saying, where do you have a negative x and a y, but they're the same number? So if I look here, do we have the same number, but the x is negative and the y is positive? Well, here they're the same number, but they're the same sign. So that doesn't work. Here they're the same number, but the x is positive, the y is negative. They're looking for a negative x and a positive y. So that does not occur, so that is undefined. Okay, so that's that part. Now just basically using the unit circle. So if I'm looking for the cosine, that means the x value of 5 pi. Remember, halfway around the unit circle is pi. So if I want 5 pi, I went around half. There's 1 pi. There's 2 pi, 3 pi, 4 pi, 5 pi. 5 pi would be right here. The cosine is the x value. So the cosine of the cosine of 5 pi is negative 1. Negative 2 pi. So I go negative direction, 2 pi. 2 pi is all the way around the circle. So I would end right back where I started. The cosine, the x value is a 1. 17 pi over 2. When you're doing pi over 2, that's where you have to include both the x and the y-axis, because notice this is where you have your denominators of 2 occurring. So if I'm going 17, here's 1 pi over 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 pi over 2 would end right here. The cosine, the x value is 0. What if I go negative 13 pi over 2? So again, it's pi over 2, but I'm going negative 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here's negative 13 pi over 2. The cosine is 0. That is the end of 8.2. Again, main thing is if you are given a triangle, can you use SOHCAHTOA to set up equations using sine, cosine, and tangent to find missing values? Then, can you use the unit circle, remembering that the cosine is x, the sine is y? They will give you restricted domains, meaning sometimes you will get things that would be undefined. I hope you enjoyed our time together today, and I'll talk to you soon.